Hi, this is Ms. Cho, and in this video, we'll solve a quadratic linear system of equations. When we talk about a system of equations, we're talking about plotting two things on the same graph at the same time. So in this situation, we have a parabola and a line, and we want to know how many different solutions there can be. Solutions are intersections on a graph, or points that make both equations true. We can see that we can have two solutions. It's also possible to have one solution or zero solutions. Let's take a look at what this means algebraically. In this example, we're asked to solve the system of equations y equals negative 3x squared plus x plus 4 and 4x minus y is equal to 2. This is a long process, and our first step is to solve our linear equation for y. Our equation is 4x minus y equals 2, and I want to solve it for y, so I'm going to add y to both sides, which leaves me with 4x is equal to 2 plus y, and then I subtract 2 from each side, leaving me y is equal to 4x minus 2. Now that I have an expression for y equals, I want to substitute the y in place of the y in the quadratic. My quadratic equation is y is equal to negative 3x squared plus x plus 4. And I know from above that my y is equal to 4x minus 2. So I can set the left side equal to 4x minus 2. And now I have a new equation, which I'll call equation 3. My third step will be to set equation 3 equal to 0. To set one side equal to 0, I'm going to move everything on that side over to the other. I want to end up with a positive quadratic term, and I notice that I have a negative x squared term here, so I'm going to add 3x squared to both sides. And then I will subtract x, and then subtract 4, and that will cancel out all my right side to 0. On my left side, I have 3x squared, 4x minus x is 3x, negative 2 minus 4 is negative 6. My fourth step will be to solve this equation using any of the methods that we've learned previously. I'm going to solve this by factoring. I see that my a is 3, my b is 3, and my c is negative 6. When I multiply a and c, I get negative 18, and my factors of 18 are 1 and 18, 2 and 9, and 3 and 6. I'm looking for a pair of numbers that will add up to 3, and I notice that I can get that by having a positive 6 and a negative 3. I'm going to factor by grouping by rewriting my first term, leaving a space for my b's, and then rewriting my last term. My b's are negative 3x and a positive 6x. From there, I can factor out the GCF of each group. In my first group, my GCF is 3x, and I am left with an x minus 1. In my second group, my GCF is 6, and I am left with x minus 1. Since my terms in parentheses are identical, I can continue, so 3x plus 6 and x minus 1 are equal to 0. Here, I can use the zero product rule and set each factor equal to 0 and solve for x. When I do that, I have x equals negative 2 and x equals 1. Are these my solutions? No, because solutions are in the form xy, and right now I have an x and I have another x, but I don't have the y's. So my next step will be to find the y's that go with each x. The way that I'm going to find the y's is to use the equations I'm given. I could use either one of them, but I'm going to use the linear one because I think it's a little simpler. I'm going to rewrite 4x minus y is equal to 2, and then I'm going to substitute in the x that I have in order to solve for y. So here my x is 1, and 4 minus y equals 2 gives me y is equal to 2. When my x is negative 2, 4 times negative 2 minus y equals 2. Negative 8 minus y is equal to 2, and that gives me y is equal to negative 10. Now that I have my x values and my y values, I can rewrite this as ordered pairs x, y. My first ordered pair is 1, 2, and my second ordered pair is negative 2, negative 10. From here, my last step is to check that each of these solutions satisfies both equations that I started with. To check algebraically, I have to plug in each point into each equation. So I'm going to start with equation 1, or y is equal to negative 3x squared plus x plus 4. And I'm going to check both points, 1, 2, and negative 2, negative 10. Plugging in gives me y is equal to negative 3 times 1 squared plus 1 plus 4, and I want to know if that equals the 2. And on the other side, plugging in gives me negative 10 is equal to negative 3 times negative 2 squared plus negative 2 plus 4. I'm going to pause the video now and finish the check. My first equation has both points on it, so now I'm going to check my second one. 4x minus y is equal to 2, and I'm going to check 1, 2, and negative 2, negative 10. Plugging in again gives me 4 times 1 minus 2. I want to know if that equals 2, and then I have 4 times negative 2 minus a negative 10, and I want to know if that equals 2. I'm going to pause the video here and finish checking. My second equation has both points on it, so now I know that my two solutions, 1, 2, and negative 2, negative 10, really are my solutions. I can also verify this graphically using Desmos. On this graph, I can see that my solution 1, 2 is on both the line and the parabola, and my solution negative 2, negative 10 is also on both. To summarize, when you solve a quadratic linear system of equations, the first thing you're going to do is rewrite your linear equation in y equals mx plus b form. That way, you'd have an expression for y equals that you can substitute in the place of y in the quadratic equation. From there, you set your new equation equal to 0, and then you solve that using any method you like. Once you have solved your quadratic equation, you need to find y by plugging in your x values into the original equations. Then you're going to write your solutions as ordered pairs x, y, and then you're going to check that all your solutions make both equations true.